Relational databases can be quite tricky. Trying to apply normalization properly can be confusing. Once you do normalize a database, inserting becomes more complicated because you have to do multiple inserts just to add a new person with their address and phone number. Plus, you have to do those inserts in a correct order in order to get the identity values back in order to create that final record. Once the records are in the database, getting them back out can also be a challenge. Inner joins, outer joins, grouping, and more can be difficult things to get right all the time. NoSQL databases are designed to address these issues and more. In this video, we're going to look at MongoDB and how to get started in using it in C#. Along the way, we'll discuss what NoSQL databases are and when to use one over a relational database like SQL Server. But before we get started, if you're new to this channel, my name is Tim Corey, and it's my goal to make learning C# easier. Whether you're new to C# or have used it for years, you should be able to find something here that will benefit you. Now, if you're interested in getting course discounts and other perks, sign up for my mailing list. The link to do so is in the description. Also, make sure you subscribe to this channel so you can get alerted when I post new content. I'll post new videos every Monday and Thursday with occasional bonus videos beyond that. Okay, to start, we're going to install the necessary items to get started with MongoDB. That way, you can follow right along and have MongoDB running on your machine as well. Once we get it hooked up to C#, we'll discuss what it is and when we should use it. That way, we have something in front of us to help us grasp the concepts we're talking about. So, the easiest way to get to MongoDB is just type a search, MongoDB. And the first thing that comes up is actually mongodb.com. This is what we're looking for. Now, this website can be a little bit confusing at times, especially in mouse order products, and there's a lot here. And it's not all free. But don't worry, all the stuff we'll be using is free. So we want the MongoDB server. We click that and say download the latest release, which is currently 4.0, actually 4.0.9. It takes us here. And again, it says get started free. Don't click this. Don't start here. This is for the Atlas Global Cloud Database. It's a little bit different. It allows you to do cloud-based Mongo easily. Now, going forward, we'll be working with Azure with MongoDB. But for this video, we're just going to do it locally, not even having redundant databases, which is very easy to do with MongoDB. So instead what we want the server in the middle. And this is the community server, which is free. So as you can see, the current version is 4.0.9. And because I'm running Windows 10, 64-bit, it says, okay, that's what you're using. Therefore, that's what the version will give you. But there's many other versions to choose from if you are on a different machine. And the package to install it is an MSI. Okay. Now I've already downloaded it. So what I'm going to go to my downloads and just kick off this process. All right. So I just started the process. I'm going to hit next, accept the terms, and I'm going to say custom just to show you there's not a whole lot to configure, but if you want to come in here and make some modifications to what it does, you could, but for the most part, it's leave it alone, leave it, install it where it should, and hit next. Now, this is going to install MongoDB as a service, which is good. That way, it will run even when I'm not logged in. Now, services run under a set permission set. So in this case, it's saying by default, we're going to run it as the network service user, and that's fine. That's all we needed to do. However, if we're on a domain or if we had a different login we wanted to give it, we could select this and give it the domain, the username, and the password. And then it could be a specific user that this runs underneath. And that doesn't mean it will run by logging into that profile. It doesn't mean it will run only when that user is using it. What it means is it uses the permissions of that user to do its work. But in this case, we want to leave the default as the network service user. And the service name is going to be called MongoDB. It's kind of neat. We can modify that to whatever you want, but MongoDB is fine. Now, the next two things here are the data directory and logs directory. This is where we're going to store our databases, or the equivalent of our databases. NoSQL has some different terminology, but it's the equivalent of a database. So our data directory is inside of our program files. We have MongoDB. Inside of that, we'll have server 4.0, and then the data folder or the logs folder. That's fine. Now, if you do want to move it somewhere else, you can. So it's up to you if you want to store your databases somewhere else. We hit next. And before you hit next again, there's this checkbox down here that says install MongoDB Compass. And what that is the equivalent of SSMS for SQL. It's the front-end GUI to work with your databases. We do want to install that. So make sure that's checked, hit next, and begin the installation process. Now it gives me my UAC prompt, and now it started the actual installation. This shouldn't take very long. It's a pretty quick process just to get things up and running. It's already installed the MongoDB server, and now it's installing Compass, which takes a couple minutes for itself. But once we're done this, we'll have the equivalent of SQL Server and SSMS on our machine, but for Mongo. So it's going to be a Mongo database engine and server, and it will be the Mongo GUI for working with the databases, and that's the Compass. All right, now that it's done, it's popped up the Compass. So it's got the default connection, or the new connection for connecting to a database. And right now, everything's filled out as default, and we're going to leave everything just as it is. We're just getting started with MongoDB. We're not going to go too deep into creating authentication or any of these other things, including SSL, because it's all going to be local stuff. Now, you can do all of this, and it's not that hard to do. But for now, we're going to leave it all alone and say connect. Once it loads, it'll load the databases that are already existing. We have local, which has a startup log. We have config, which has nothing. And we have admin, which has nothing. So those are the three databases that we have in our cluster. That's what started off with. So now we can create a new database right here if we wanted to. Or we can wait, which we're going to wait. We're going to create it in C#. But that's the basic view of Compass. So I'll drag this off and we'll bring it back when we create a database. All right, hit finish on the setup, and we can close this down. So now that we have this installed, let's open up Visual Studio, and we're going to come down here and create a new project, and let's create a console app. Nothing too fancy for this first demo. We're going to just get used to working with Mongo. We are going to use some, I don't want to call them advanced features, but we're going to definitely do connecting to the database. We're going to insert records. We're going to update records. We're going to delete records. We're going to read records out, all those good things. So it's going to be a full demo, but it's not going to be wiring up to a full user interface and all the rest. That's really not necessary to show off Mongo. So console app, I'm using .NET Core and C#. We hit next. And let's call this the MongoDB demo and MongoDB demo app. And hit create. And there we go. And now we can get rid of our console write line. We can put our console.read line at the end. And now we're ready to get started working with Mongo. So the first thing to do is to right-click on dependencies and say Manage NuGet Packages. And we're going to look for our MongoDB driver. So search MongoDB, and the first option we get is the official .NET driver for MongoDB. Select that. The latest stable version is 2.8. That's good. and that also works with .NET Standard version 1.5 or higher. And it also works with .NET Framework 5 or 4.5.2, and of course .NET Framework Core. Or .NET Core, sorry. So this will work really in just about anywhere you want to take it. And so if we're going to create a class library, which we won't do for this project, but we would do in a full project, I would create a .NET Standard class library because we have that opportunity. And that way, not only will it work in .NET Core, but it'll also work in our .NET Framework projects, and it will work in our Xamarin projects. So it kind of works across those different platforms. But for now, what we're going to do is just say install this and hit OK to install it. And I accept for accepting the terms. And now we're installed. So now it's installed, what we're going to do is I'm actually going to create a little helper class. And it's going to be not quite so little after a little bit. I got a public class. I'm going to call it Mongo CRUD. It's going to do all the create, read, update, and delete actions. Now I'm creating it right inside of this same program.cs file, which seems like a bad thing, except this is my new habit. It used to be, if you want to create a new class, you would right click on the project, say add class, give it a name, and then start filling it out. The problem is that then you have to split your view in order to see both static void main, where you're going to call this, and see the class that you're actually writing. What I want to do is write the class here and then use it up here. That allows me to see a little bit closer to what I'm doing without having to split those views. Then, when I'm ready, I'll just do select MongoDB CRUD or Mongo CRUD and say control dot and move type to mongocrud.cs. So create the file for me and put it in the same directory. That way, it's just a little simpler to develop, and yet I still haven't lost any of that best practices about separating these out into their own files. Now, if you want to do that or not, it's up to you, but that's the kind of the habit I've gotten into, especially with doing it on video. It just allows me to use a little more screen real estate a little more efficiently. Okay, so let's talk about our first command, which is going to be, we're going to create a connection to the database. And the way I'm going to do this is I'm going to create an iMongo database, which I do control dot and add the using statement for that. Let's go call it DB. This will actually be private. And I'll create a constructor. And in that constructor, we're going to pass in a database name. Now that we have a database name being passed in, what we can do is say var client equals new Mongo client. That creates a new client that can be used with MongoDB. And the reason we're doing it internal to this constructor is because of the next line. DB equals client.getDatabase and pass in the database name, which comes in from the constructor. So essentially these two lines right here initialize this DB property and connect to that database. So it opens a connection right there. Now what this allows you to do is it allows you to do one of two things. Either it allows you to create a connection once and use it throughout the rest of your class up here in static void main, or it allows you to create the connection, open it up, do the work, close it, and get out. So you have both options available to you so that whatever your environment needs, it can do. Okay, so you have those, it basically just keeps your options open. So that is how we're going to connect to our database. So up here, what we do is we'd say Mongo CRUD, and we'll call this DB for database. equals new Mongo CRUD, or I'll pass in a name. Now, we don't have a database yet, but this is one of the ways that MongoDB is a little bit different. We're going to give it a name right now. Let's call this our address book. Yeah, I think that works. Address book. Okay. So this will do, it will get that database if it's available. If it's not, what it will do is we will create that database when we need to. So it's already a little more flexible than SQL is, because if we try to connect even to a SQL database that's not there, it's going to time out. But with this, it will actually say, oh, you don't have one? We can create one for you. Now, the other thing to note here is there's no connection string. The connection string would go right here. In fact, if we do Control-Shift-Space, we have 4 options here. One is to initialize like this. And what this does is it connects to our local host with no login name and password. So it connects to that same database that we saw, or the same server as this right here. Okay. So that's the first option. Now the other options are to pass in, well, it kind of goes off the screen there. Sorry, my screen's a little wider than what I'm recording. The Mongo client settings, we have a URL or we have a connection string. So our 3 other options. Connection strings are probably the most popular. And if you go to the Mongo site, they'll give you some documentation on how to create those. In a future video, I'll go through connecting to those and connecting actually to clusters of Mongo databases. But for now, we're going to use the basics, which connects to the server essentially that's running locally. So now let's create a method in our class down here. Let's call this the insert record method. So public void, it's not going to return anything, it's just going to insert the record. Insert record, and let's say it's going to pass in a type T, and that type is the actual record. So string, table, and T is the record. And what we'll do is we'll say var collection equals db.get collection of type T from the table. So the first thing it does is it gets that collection, or you could think of it like a table. That's why I call it table here, because that's kind of the noun we're familiar with when it comes to working with data. We're going to get a table, which is a set of records. It's going to get that collection. And then what it's going to do is it's going to insert one record. So collection.insert, we have 4 options here. Many async, one async. So we're going to insert 1 here, and here's the record. And we're done. That's an insert statement. Okay. Now I've made it generic. So we're passing in T here. Why did I do that? Well, because, and this is where we're going to start getting the philosophy of NoSQL. We haven't defined, well, first of all, we haven't created anything yet. We've said address book, okay, which doesn't exist yet. And let me just kind of clue you into the next step, which is that we're going to say db.insert record. To pass in a value, we'll do that in a minute. And then what we'll do, let's just say the table name is going to be, users. And the record, we're going to have to say, we'll create that. But that'll be some kind of object, okay? Which that's not what that is, but we'll start there. So we'll pass in some kind of object, like a person model or an address model or something like that. We're going to pass whatever type of model you want into here, and it's going to take that, and it's going to, well, here, let's just, there, it's not, that won't yell at us. It's going to take this object, whatever it is, whether it's string, whether it's a a full object. We want a full object, like a full model. It's going to take that. It's going to say, okay, this table, it's all of this type, whatever that is. So in this case, string, but more likely a person model or an address model. And it's going to insert a new one. Now, I haven't defined a users table. I haven't defined an address book. And I haven't defined what my columns are. So how does it do that? Well, MongoDB is a NoSQL database. And NoSQL databases, you can think of them, the best way to think of them is, as a developer is to think of them as just storing our objects. So let's create an object. Let's create our person. So public class person model. And we'll have a first name and a last name. Okay, pretty simple stuff here. And so we'll say here, we'll say new person model. And first name equals Tim and last name equals Corey. Okay, so we're going to take a new person model object and insert it into the users table. We haven't defined a users table, so we definitely haven't defined a first name column or a last name column. But this will work, which sounds a little weird. But what it's doing is it's essentially converting this person model object into JSON, which is a JavaScript object notation. And it's going to insert that into the database. Now, technically, behind the scenes, it's what's called BSON. Instead of JSON, it's BSON. And that's Mongo's way of optimizing things. And there's some stuff behind the scenes there, but essentially, it's just JSON. Okay? So it's going to take this object, whatever it is, and store it as a record in our table. So it's going to create the database, create the table, and then put this record into this table or collection. Okay? So that's the basic structure of MongoDB, meaning there isn't really a structure, because I could then do another insert and have a totally different structure if I wanted to. Not ideal, but you could. So let's start by just inserting this record. Now I'm going to add one more thing to this. So I'm going to come up here and I'm going to add a ID field. So public, I'm call it a GUID. I'll call it ID, and I could unprop, but get and set. And this is actually, we're going to label this specially as BSON ID. Control dot that to add the using statement. And what this is doing is saying, hey Mongo, this is your ID, this property right here. Because behind the scenes, what's going to happen is it's going to store this as the ID field, this underscore all lowercase ID. That's what it's going to store it as. But we're saying, yeah, we know you want to store it that way, but we want to name it ID with a capital I and no underscore. It's going to map that over. Okay, so that's going to be the unique identifier for this record. Now, I haven't given it a GUID, but since the GUID is null, when we go and insert it, MongoDB is smart enough to go, oh, you don't have one yet. Let's go ahead and create one for you. This is really helpful because what we can do is we can check a person model object and say, hey, is your GUID null? If so, that's an insert. Otherwise, it's an update. Okay, so that's a way to make things a little easier for ourselves. So with that being done, we haven't changed anything here. And all we're doing is connecting to the database and then inserting a record. Now over here, there is there's no collection here called users. Okay, it's just admin, config, and local. And if I hit the refresh here, which is somewhere, there it is. There's no fourth item here. So just note that when we run this code. So let's run this. And once this compiles, it builds. And now the cursor is blinking here. If I hit enter, the program is done. If I move this back over, I hit the refresh. Now we have address book, which has users inside of it. Inside the users, we see this record here. And let's see if we can zoom in here. There we go. So we have this record here. Notice the underscore ID. And it has a binary, but that'll get converted to a GUID. We have the first name field, and we have the last name field, and that's Tim and Corey. So that's a record, also known as a document in our collection. So that's where it's a little bit different as far as terminology goes compared to what you would see in SQL. Because SQL would say, well, this is a row. Well, it's not a row, it's a document. And why is it a document? Well, because this is a document database, meaning it stores documents. And this is a document right here. So a document stores all the information about something. Okay? So in this case, it's just our first and last name. Now, if we run this again, let's modify this to be Mary and Jones. And we'll run it again. And we can hit our enter to escape or be done. Come back over here and hit refresh. And now we have two records. We have our Mary Jones and we also have our Tim Corey. So there's two different records now in our database. So that's MongoDB. Without setting anything up, really. We just said, you know what? Give me address book as a database. Users is the table equivalent, also known as a collection. And then insert records, also known as documents. So there's our naming differences. We have address book as our database, but then users is a collection. Okay? Because we call these documents. So what's a set of documents? Also known as a collection of documents. So that's the terminology difference. Now I promise we're going to speed up with the C# code, but I kind of want to go over and make sure you get a grasp of what's going on here. Now, let's make one more change here. This isn't enough because first name and last name, not enough for an address book. I really want to have addresses. So let's create another class, address model. And we'll say that it has a street address, a city, a state, and a zip code. Okay? Now, up here, we can say, let's go with address model and primary address. And we'll leave it at that for now. Now notice I just changed my model, my person model, which person models go in the users table. But the first two don't have the address model called primary addresses. What's going to happen if we add something that does? Well, let's find out. First of all, let's expand this out by actually creating a real person model. Person equals new person model. Actually, let's do this, and we'll say first name equals Joe and last name equals Smith, and we'll call that good for now, but then we'll say person dot primary address equals, we could do it in line, I don't want to get too confusing. Primary address equals new address model, like so. And we'll do street address equals 101 Oak Street. City equals, Scranton's fine. State equals PA. And zip code equals 18512. Sounds about right. So now we have a new, more complex person model. We're going to insert that into the users table. This does not match the same structure as the previous two. But if we run this, we come back over here and we refresh this list, we'll see that, in fact, we still have our, actually, let's zoom in this way. There we go. We still have our first two records, which just have first name and last name and the ID. But we also have this one down here, which is first name Joe, last name Smith, and it has a primary address object, which has street address, city, state, and zip. So why does it work this way? Well, this is one of the benefits of NoSQL, is it doesn't really enforce that you conform to a certain structure. Now, this may sound like chaos at first, but if you think about it, this actually can make your life amazing. Because let's talk about a customer record for a minute. So you have a customer. Your customer's name is Joe Smith. And you have a primary address. And you've used just primary address for a while. Now, if your boss comes to you and says, yeah, we really need to have a secondary address now, or a billing address, let's call it that. If you're a relational database, you'd have to add a new column to the person record probably, and then add a new type to your primary or your address columns because it can't be the same possibly. And then you'd have to, fill all those things in, or you'd have problems when it comes to customers who don't have a billing address labeled. How you gonna link that, because you really shouldn't have null there, and all those weird problems. With this, not so much. You can just add to your model business address, and as you get them, they get added. And then if you're reading records in, you can just check to see if the primary address or business address is null. If it's null, they don't have one. If it's not null, you read it. Okay? So it makes it a lot easier to adjust to new circumstances over time, and your user's information doesn't get lost. Because right now, this document about Joe Smith holds everything we know about Joe Smith. I can keep adding to it over time, and that's the right way of going about it typically when we're dealing with MongoDB. I don't have to add more tables and link them in. Primarily, when you're dealing with NoSQL, you're not dealing with complex joins and querying. We're not normalizing our data. Now, the reason why we're putting all of our data here, which might cause duplication, which you might cringe at, but the reason we're doing it is because this is now the authority on Joe Smith, this record. It knows everything about Joe Smith. So there may be stuff in here that's duplicated for somebody else. Let's say Jane Smith, who's married to Joe. They both live at the same address. Jane Smith would also have a primary address that's the same as Joe. And you may say, man, I don't like that structure. I want to deduplicate that because we don't want to repeat ourselves. But it actually makes sense. Think of how easy it is for me to look up information about Joe Smith. It's super easy. There's no querying. Imagine how fast we can get the data out of this database. It's just ask for this record. That's it. You're done. You have all the information you need. And that's the benefit of NoSQL. What they do is they trade space for speed. So a NoSQL database will use up more space than a SQL Server database, meaning SQL Server is more efficient in how it stores data on the disk. MongoDB doesn't really care about how much data it stores on a disk, and so it can duplicate those records all at once, because what it wants to do is it wants to get information in and out very, very fast. That's a great value for things like Facebook, Twitter, or other things where you have tons and tons of records being written very, very quickly. SQL databases just simply can't keep up with all those reads and putting them in different spots. Or at least it's much more difficult to. With MongoDB, it's saying, you know what? I really care about speed, speed, speed. So that's what I'm going to focus on. And that's what it does. Now, there still is the concept of multiple tables. So don't think that one table holds everything. You may have a separate table for something else. Let's say parts list or inventory or something like that you might have. But you have one record in there that kind of holds a bunch of information that might be otherwise split apart in a normalized database. Okay? So let's get back. That's all a lot of theory. Let's get back to the practice of it. So we have, let's collapse these for now. We have our insert record, which that's working great. And we're inserting our new person. But let's get some records back. So let's start with a read. Now that we have some data there, let's create a new method. Let's call it public list of, list. I don't have system collection generic on my using statement yet. So list of type T, load records of type T from the table that you pass in. Okay, so we're going to say whatever model you want, that's what will populate with records from whatever table you give us. So we're going to start with var collection equals db get collection of type T from that table. And then return collection dot find new bson document which that's, there we go, control dot fix that, new bson document, and then we're going to return that to list. Okay, because find actually returns an I find fluent. But what we want is just a list. Okay, so this is all there is to searching for basically select star. Okay, select star is actually the better way of going about it when we're talking about NoSQL. It's actually faster. So there's no filtering, there's no processing on the database side. We're saying, you know what, just give us all the records. Obviously, if you have 1 million records, maybe not practical. But for most smaller to moderate size lists, this is actually more practical. So let's go up here now and make that call. So I'm going to comment out this right here. We don't need to insert a new record every time. But now what we'll do is let's just say var records or x equals db dot load records of type, and the type is going to be person model. And we'll pull it from the users table. Okay, so this is our select star from, but it's just saying this is the model I want to use, this is the table I want to use, give me everything. And that's going to be this rex list, which will end up being a list of person model. Now, what I'm going to do, instead of doing a for each and looping over them, I'm just going to, well, you know what? I'm going to do that. I'm going to do a for each, but I want to show you how to deal with not having the primary address. So let's do a for each. And we'll say for each rec in recs. And we'll start off by just doing a console write line. And we'll do our $, which is our string interpolation. And we'll start off with rec.id, just to print off that GUID and show it really is a GUID. And then we'll do rec.firstname space rec.lastname, like so. And now it's going to print off, in this case, it's going to print the GUID and then Joe Smith. But we want to also see if we have an address. So if rec.primaryAddress is not equal to null, then we'll also print off the address. Let's just print off a city. Just keep it simple. So rec.primaryAddress.city. Just something simple to make sure we have something. And we'll do a console write line with a blank line at the end. That way we can see all of our records in our database, and if they have a primary address, which city the user is located in. Let's run this. And there we go. There's the GUID, Tim Corey. There's a GUID, Mary Jones. There's a GUID, Joe Smith from Scranton. Okay, so that's how we deal with the idea that not all the data might be there. So I can close that out. That's how we do a read. But you say, you know what? I don't want to always read everything. Maybe I want to read only certain records. And that's fine. Let's figure out how to do that. Let's collapse some of these. And let's create a new method. So public T load record by ID. That one of type T, and we'll say string table and the GUID ID. So you have a GUID and you want to find that record in the database. So var collection equals db.getCollection of type T from the table that you pass in, just like up here. But now we have a filter. Var filter, this is kind of our where clause, equals builders of type T dot filter, dot EQ for equal. And we're going to say the ID is going to equal whatever ID passed in. So it's going to filter on the ID field and say it's going to match up with this. Now what we can do is say return collection dot find. We have a few options here. Find async, find one and delete, replace, update, or sync. Okay? So we're just going to do a find. We don't want to do anything to the record except return it. We're going to do a find. We're going to pass in the filter we just created. And we'll say first because we only want one of them. We don't want all of them. Now, we could say just find. It's going to return an iFluent, which I believe we could just do a toList and have all of them and return a list of T. But since we're returning or looking based off the GUID, there should only be one. Therefore, we're only going to return one and not have to have the user mess with that. Okay? So now what we'll do is we'll actually go up here and call this. So let's come up here. And instead of this right here, we'll comment that out. And what we'll do is we will say db dot find. Why aren't you coming up? It's not find, it's load. Load records by ID. The table is users. Now, if you haven't noticed already, these kind of magic strings here, you probably want to put those into variables. That way it's a whole lot easier. So just note that we're doing this for demo purposes. So now we need a GUID. Well, how do you create a GUID? Or how do you get the GUID out of the database? So what we're going to do, the easiest thing to do is we're actually going to pull it from reading all of our records. Okay? And the reason why is because if I go over here to my Explorer and try to copy something, that's the binary version. I don't want the binary version. It's hard to read and hard to convert. So instead what I'll do is I'll comment this out real quick. And I'm going to uncomment this and put a breakpoint right here. This is kind of half cheating for demo purposes, but that's okay. Come down here to records. Let's grab the big one. And there's my GUID right there. So I can grab everything between the curly braces and copy it. And now I'll stop. And I'm going to say uncomment this. I'm going to say new GUID. And pass in our GUID. Okay. And there we go. That's our GUID. So you can't just pass a string in, you actually gotta say new GUID. And it's yelling at me for some reason. We're gonna find out why in just a second. I didn't give it a type. So I need a person model back. That's why. Okay, so you can't just call this, you actually have to declare this is a person model because we're not using person model anywhere in any of our variables being passed in. So we can't infer it from a type. Therefore, we have to tell it explicitly it's a person model. So now let's just capture this var one_rec equals, and yes, these variable names are horrible, but that's okay. I'll put a breakpoint here. We're going to run this again. And we get one_rec. If we notice down here, it's Joe Smith. There's the ID for Joe. This is the primary address, which is Scranton, PA, 101 Oak Street and 18512. So that's how we can look up someone based upon a criteria. In this case, the criteria was the ID. So I said filter, we're going to do an equals, which you have other options here besides equals, where it's empty, where it matches, and there's a whole bunch of LT for less than, greater than or equal to. There's a whole bunch of things. But that's the simplest one, and it's probably one you're going to use probably quite often, especially if you want to look up a user again or refresh data or compare it, whatever. That's a quick way of finding a user based upon their ID. Now let's show off a few more things before we wrap up. So I'm going to create a couple more methods. I'm going to do them kind of in a row, and then we'll use them and we'll talk about them as we go. So the first one we're going to create is public void upsert records. Upsert record. And we'll say it's of type T. And it's going to pass in a table name. It's going to pass in a GUID for the ID and a record. Okay, so what an upsert is, it's actually a word. It's not something I made up, although it kind of is made up. But the idea is it does an insert or an update, depending on what is necessary or what is needed. In SQL, we used to create upsert statements, and now we have merge statements. This is kind of similar, where it's going to do a merge, where it's going to say, okay, if it's already available, then update it. Otherwise, create it. Okay, so we're going to start off like we do every time. In fact, we could probably just copy this line right here. So var collection equals db.get collection of type T, and get our table. And then we'll do is say var result equals collection dot replace one. And then we have a few options here. New bson document. Looks familiar? This is kind of our mapping of looking up information. So we're going to say, we're going to look up in the ID column. This is the actual raw ID column. So underscore lowercase ID. We're going to pass in the ID that we passed in. So it's going to look up to see if, based upon the ID matching this, if we find a match, it's an update. Otherwise, it's a insert. We'll pass in our record next, and then we'll pass in new update options is upsert equals true. Okay, let's talk about this. So we're going to tell our collection we want to replace one. And so what this is doing is we call it an update, but it's not technically an update. It's actually, if you find an ID that matches the ID we're passing in. So look at all the IDs in your collection and see if you find one that matches this value. If you do, I want you to basically delete that record and put this record in its place. Otherwise, if you don't find a match, insert this record as a new record in this collection. And that's where this is upsert equals true. Is if it does not find a match, it's going to insert the record. Because this is actually a replace. But what happens if you try to replace something that's not there? Well, as long as you have is upsert equals true set, it will insert it. Okay? So that's what that command is doing. And that's the result we're not going to actually capture, but we capture, we're not going to use it. But that's going to do an upsert. And we'll get to that in just a minute. But first, let's create one more, and that is public void delete record of type T, table, and GUID ID. So this is pretty straightforward. We're going to start off like we always do, the collection. And then we're going to say we need to do a filter. So var filter equals builders of type T dot filter dot equals, and it's ID, and pass in our ID passed into our method. And then collection dot delete one, and you pass in that filter. So that's a delete record. So it looks an awful lot like our load record. We have the same filter. It's just instead of doing a find, we do a delete one. Okay? So same basic concept. So as you can see, yes, the syntax is a little squirrely. Like this builders and the filter and the bson document. Yeah, that's a little squirrely. I get it. But the cool thing is I've already written it for you. Now all you need to do is start calling these things. So let's do that. We already have a GUID here. So let's, instead of just reading it, well, you know what? We're gonna load it after we update it. Okay, so what we'll do, no, we're gonna load it, we're going to update it, and we're gonna load it again. So now we have this one record, which is a person model. We'll say one rec dot, we have last name. Let's do this. You know what? We'll go even further. We're going to say we're going to add something to our person model. Let's add Well, here's a tricky one. Date, time, date of birth. Okay? But there's two things I want to do to this. First of all, I want to put it in and have it actually store the correct values. So I'm going to have to make sure I send it in as UTC, Universal Time Code, not undefined or the local time, because otherwise it'll actually store it as 4 in the morning because I am +4. So, or -4. Yes, -4, which means it's going to be +4 of whatever I have. That's right. But the other thing is I want to change this in a database. So instead of saying date of birth in the database, it's going to say DOB. So the way to do that is to have a decorator that's bson element, and then parens, I can say DOB. And now this is going to be stored in the database as DOB, but in my model, it's date of birth. Kind of like how we mapped this ID, even though it's underscore lowercase ID, it maps to capital I lowercase d in our model. Well, here we can also map it the same way, so that if we had a existing MongoDB database we're working with, we want to change how the model looks, not a problem. We can map it this way. So that's step 1. Step 2 is to actually update our model. So 1rec.date of birth equals new date time. We're going to pass in, let's see, 1982. Let's go with October, and let's go with 31st, Halloween. And I pass in 0, 0, and 0 for hours, minutes, and seconds. But I'm not quite done yet. I also need to pass in a date time kind. And the kind I want is UTC. That way it makes sure that it's actually at midnight. Basically, I don't care about the time, but I don't want to have a time in there other than 0. Otherwise, I might think we do care about the time. So that's just a note. That's how you do UTC time. So now that I have this, I can say db.upsert record, and I'm going to pass in the table name, users. I'm going to pass in the GUID, which is the same GUID we already have, but I can also just say 1rec.id, and the record is 1rec. All right, so that's my upsert. And it should be, if we read this back again, we'll have the full information. But what I'll do is I'll look at it in the Compass app. Okay, so let's take the breakpoint off and run this again. I hit enter, close it out. I refresh my data. And now, if you can see this, Joe Smith has a date of birth of 1982, October 31st at 0 time. Okay? And the primary address is still the same. So we've updated the Joe Smith record. Right? So that's how we do an update. But what if we say, you know what? We're tired of Joe Smith. Let's get rid of him. Not a problem. So instead of doing our update, what we'll do is instead we'll say db.delete record. And the record, we got to give it a person model. The record is going to be in the users table, and the GUID is going to be 1rec.id. We're still loading that up here. Now let's run this. And we can close that back out. We can come over here and refresh our data, and now Joe Smith is gone. All right, so that's a delete statement. Now, so far, I have tweaked the person model a little bit, but not a ton. Okay, and we've always been adding things to it. But what if I create a new model? let's just say I create a public class, let's call it name model for like a better name. And I'm going to say I just want the first name and the last name. That's it. Not an ID, not primary address, not date of birth, just first and last name. That's it. So let's comment these out and uncomment our reads. All right. And this is where it's really going to help me to have using these vars everywhere, because I can change this from person model to name model. Now, this won't really work. Whoops, name model. There we go. This won't really work because we don't actually have our primary address or city address. So let's, well, you know what? Let's copy this. That way you can still have it. I will give you this code. What I'll do instead is I will call it down here like so, and we're going to modify it to work just for the name model. There we go. Just first and last name. That's it. Let's run this. And it says, oops, element ID does not match any field or property. Load records. Let's find out why. I do need the ID. Sorry about that. That was my bad. Let's map that out. Because it still says, you know what? You've got to map it as something. Let's run it again. And there we go. Tim, Corey, and Mary Jones. So even though I didn't have all the fields that this one did, it's okay. Because I don't need all those fields. I just need the fields that I want to view. And it will map just those fields. So if I have too many, it will just not fill those in. If I have too few, it will just fill in the ones that I do have. As you saw, the one thing that I needed to include is the ID so I can identify that record. Otherwise, that's all I need. Okay? So that allows you to be very, very flexible with working with these databases, because you can say, I just want to create a model just to get certain pieces of data. Maybe all you want is dates of birth. Well, you can do that. You can create a model that's just the ID and the date of birth, and then read those in. Okay? Now, before we finish up, I'm going to do my control dot here to move each of these over to their own class file. That kind of cleans this up. But it doesn't really change anything else in this code. It all just kind of runs like it should. Okay, so with that, we've gone over how to start using MongoDB and what kind of scenarios you'd see it used for. But let's talk about a little bit about the when to use it and the why to use it. Okay, because these are kind of important things. And this is something you should ask about every tutorial you go through is, when do I use it and why do I use it? Because otherwise, you don't know how to use what you learn. You got this great new tool, but, kind of who cares? It's kind of like the infomercial you watch. You see a lot of stuff, but then you actually get the product and you're like, yeah, I don't know how to use that. Okay? I don't know when to use it. I've seen it used. I can do some great stuff, but, do I replace my, this thing with that or not? And so what we're going to do is talk through a little bit real quick about when you'd use this and why. MongoDB really is it's pretty close to a direct comparison to SQL now. And that's not something I could say a couple of years ago. A couple of years ago, this was for quick stuff you didn't really care about too much, or stuff that was, maybe offline storage, that kind of stuff, because it was very easy. It's a quick document database. But they've really come a long way, especially the 4.0 release, where now some of the things that DBAs would say about MongoDB is, well, it's not as safe and secure as SQL. Now, SQL, yes, has a ton of great security features and a ton of processes around making sure your data is safe. One of those things, though, is called ACID. The ACID test is actually an acronym. I don't know what all the 4 letters stand for, but what it does is it says, for example, if I'm going to take money out of my checking account and put it into my savings account, and I start that process, and so the bank software removes the money from my checking account and then crashes. Does that money go back into my checking account? Because if it doesn't, that's a problem, because it hasn't put it into my savings account yet. And so we call that entire process a transaction. And what a database that follows ACID needs to do is it needs to have a way of saying transactions from start to finish either work or they entirely roll back. There's not this partial transaction limbo. And it used to be Mongo couldn't do that. Now, Mongo can do full ACID, meaning if it crashes halfway through, it rolls back the transaction and your data is safe in the state it originally was. So that's a huge deal when it comes to database work and trusting it for production use in a real environment. So why would you use MongoDB? Well, MongoDB is very, very, very fast. As you saw, there's not a lot of querying because all the information comes back as one big object, and it may feel a little inefficient. And yes, if you have 1 million records with tons of data in it, you shouldn't do that read everything because that would be pretty inefficient. But on the other hand, when you're talking about loading a customer record, if you have to say, give me this customer, and you pass in the GUID, and it gives you all the information about that customer, that's super efficient compared to SQL, where you might have to do 5, 10, 30, 50 joins to get all that data, and the SQL server is going to have to crunch all that data and figure out where it all comes from, map it over, create the query plan, all the rest. So this can be super efficient. This is also cross-platform, which Microsoft SQL is too now, but it's also a lot cheaper. Okay? It's also something that can be run on a mobile device, or it can be run in the cloud, or it can be run across the globe in a synchronized way. So you can have multiple databases that are all synchronized together. And that was that Mongo Atlas we saw that wasn't free, but it had a free trial. That's what you can do with that. Now, Microsoft has recognized the value in these NoSQL databases. So the company that makes Microsoft SQL says, yes, NoSQL has a place. In fact, in Azure, one of the big database types is called Cosmos DB. And that is a NoSQL database, and it even has connection points that map to and are written by Mongo. So it will work with MongoDB databases. So you can actually use Cosmos DB with your Mongo databases. So really, there's a lot of uses for NoSQL databases. It does change the way you think about storing data. You're not thinking about breaking things apart into separate pieces and storing them in different tables. you're thinking instead about what are the records that I want and how do I structure my application to use those records efficiently. And so when you're thinking through which to choose, there's not an easy, this is the way to go. Okay. And that's I think the biggest takeaway is if you hear someone say there's only one option, they're probably not thinking through the entire picture. Okay. So I want you to take a step back and say, let's evaluate and see what do we need in this particular situation. When it comes to microservices, and that's a big buzzword, and here's a little spoiler, but microservices aren't for everybody. Okay, I'm going to tell you that right up front. Because you may have heard microservices and microservices is the way to go, and everybody's doing microservices, and we need to do it too. Microservices are very, very difficult. They're not simple. They're not easy, and it doesn't make every environment better. But if you're going to use microservices, one of the things that comes with that is the idea that data lives with that microservice. You don't have a central database that everything talks to, because that defeats the purpose of microservices. Instead, each microservice contains with it a database. That's where MongoDB really shines, because it's very easy to spin up these little databases with these records where all the information is stored, in one record, and it's very quick to access and it's very quick to read and write. Another possibility or another reason why MongoDB might be the right choice is if you have super high volume writes. So if you're getting a ton of information, let's just say your Twitter, how many tweets are happening every 60 seconds? I think it's like 11 million or something, crazy like that. Well, all those tweets, if you're writing that to a database, that can be really, really hard. MongoDB can make that easier because it's very, very quick to write to the database. Now, on the other hand, when it comes to Microsoft SQL or other relational databases, there's definitely a place for them as well. First of all, they have a much more mature tool set. MongoDB is getting mature. It's been around for a long time, and 4.0 definitely takes its maturity to the next level. But SQL Server has been around for a long time, and it's super optimized. And so if you need that super optimization on how it runs and how it stores data, that's an important thing to think through. Okay? If you already have data in a relational database, moving it to Mongo is not a trivial task. Okay? You can't just say table for table, Matt, move it over. That defeats the purpose of MongoDB. But it does allow you to kind of rethink that and reshape that as you move it over. It just means it's not a simple process. So SQL Server has other benefits as well, especially if you have a team that already uses SQL Server. It's also a little more intuitive in some ways. But the balance is going to have to come down to what does your team know best? What does the situation need? And how can we best make use of whatever tool we have? Okay? I will say, if you're building an application from scratch, we're going to call it greenfield development. And greenfield just means no one's used your application yet. You're starting from scratch and you're building up, versus brownfield, which is where you have an existing application you're trying to modify. So if you have a greenfield application, MongoDB really does offer a lot of benefit here. Because as you saw, when I was building out this person model, I started with just these three properties. And then I said, oh, you know what? We need an address model. And I added it. I didn't have to change queries. I didn't have to change my tables. I didn't have to change store procedures. I just added that extra thing. And the old records were just how they were, but the new records would now have that address model. And it just works. Okay? So we're talking about rapid iteration of your application and your database at the same time, MongoDB really makes it easy to do that. SQL Server makes it a little more difficult, and that's why you kind of map out our database first and try and get it right in the first go. Even though we never do, we have to make modifications. So that's just something to think through as you're figuring out which way to go. Okay? So that's MongoDB. I just scratched the surface. Okay, there's a lot more we can go into, but this right here, the Mongo CRUD, will really help you get started in building your own application, because a lot of this stuff I wrote it all generic so that it doesn't matter what application, what database, nothing. It just kind of works. So take this, work with it, and kind of get familiar with MongoDB yourself. Try it out. Let me know what you think. And also let me know what questions you have. That's kind of important, because if you let me know what questions you have, I'll try and put those into future videos where I use MongoDB or where I do the next level of teaching MongoDB. And I'm going to try to answer those questions and help you out. Okay? So definitely leave those comments down below. Thanks so much for watching. I know it's been a long video, but hopefully you got a lot of value out of this. And hopefully you've got one more tool in your toolbox to use. Okay? Thanks for watching. And as always, I am Tim Corey.